Is my screen visible? I have shared my PowerPoint. Can you see my
Not
presentation?
exactly, sir. Because only the functional and conceptual design, the poster is around visible.
Okay, okay, okay. I've not started yet. Okay. Okay, let's start. So, good evening, everyone. Uh, my name is Neelarnab Dutta. I am a PhD scholar and a PMRF fellow from the Department of Design, IIT Guwahati. And this is your first live session for the course Functional and the Conceptual Design. And this course was introduced to you by IIT Madras. And so, how many of you have gone through the course, the first week of course material yet? So, have you watched the video lectures from the first week?
Yes, sir.
Okay. So, this session is to help you in solving the assignments for week one. However, since the nature of the assignments uh, are objectives, so I will try to give you some insights on the core concepts from the week one lectures, which can help you in solving those assignment questions. Okay, so here is the class agenda for today. So I will cover some of the concepts from the week one lectures, and I will try to clarify your doubts if you have any. And please feel free to chat with me or ask me any question whenever you have any kind of inquiry. And this I want this session to be a bit interactive so that I can clarify your doubts efficiently. And throughout this class, I will ask you, I will give you certain questions. I will ask, I will try to understand your understanding of certain concepts so that you will be easily, you can easily solve the assignment one. And the deadline for assignment one is 10th August. Okay, so by 11:59 Indian Standard Time in the night you need to submit this, and this deadline will not get extended. So please try to submit all your assignments before the due date. Okay. So as I told you, I want this session to be interactive. So please take part in the questions that I ask. Okay, via the chat box. So chat box will be a better way of communication, because if everyone try to ask question via microphone, then it will be noisy to answer. Okay, so can you see the product in the screen? So do you recognize this image? What is this? Okay, trimmer, saver. Okay, so this is a saver. It's not a trimmer. So there's a difference between trimmer and a saver. So a trimmer, actually you can use a trimmer to trim your. So trimmer is something like this. So you have a something in the front, and you can adjust the height, and which will allow you to trim your beard. In up to some length. Okay, so depending upon your design, your setting, you can actually keep your beard up to certain length. Okay, so that's the purpose of a trimmer. But this is a shaver, so it have circular rotary blades which actually shave. It will do a clean shave to your face. Okay, so if you have gone through the first week of no course content, so I would like to ask you this first question, like what are the key aspects of a product? And you can use the microphone also. So what did you understand about the aspects of a product, and what are the key aspects of a product?
It should have a function and form.
Okay, so a product, a product can be classified into different aspects. However, from a engineering or creative design perspective, you can think about a there are two primary aspects of a product. One is the form, okay, and the other one is the function. The form also means the concept, okay. So next question is, what these aspects define? Can you answer? So what do you mean by form, and what form defines and what function define? So what form define and what function define? Please try to answer these questions. I'm asking these questions because these are in line with the assignments that you have received for week 1, and if you can answer these questions, then this will also clarify your concepts in solving those assignments. Okay, so right. Okay, Madhusudan, he wrote that function is how a product is supposed to work. Okay, and he said form is how a product is able to do that function. Okay, so you are correct, but when you are defining these terms, you need to be more precise. Okay, so a form is, so basically the form defines how the functions can be provided. Okay, so it means how functions, okay, wait, okay, how functions can be provided to a user, in a more usable way. Okay, so your definition, like how a product is supposed to work, does or how a product is able to do that function, actually does not define the form aspect of it. So Madhusudan, I just want to clarify these concepts here. So do you understand the difference? So what you define is, a form is how a product is able to do that function, okay, do particular function. And what I define here is how functions can be provided to the user in a more usable way. So here I'm not saying that the form can do the function. Okay, so basically I'm not defining like that form is able to do a function, which is not correct. The form is a, it's a more conceptually, it is the, structure or the, okay, wait, I just need to, lot of people are joining late, so I need to click, I need to admit them to join this session. Okay, anyway, so what I'm trying to define here is that form enables how functions can be provided to the user in a more usable way. Okay, and what function define is, okay, again someone is joining. Let's wait. So what function define? So function define how, so how technology and your engineering knowledge, so basically your technical knowledge as well as engineering knowledge can be integrated to serve the overall operation of a product. Okay, so for example, so I'll give you example. uh, See, if I talk about function, so what are the functional elements of this particular, saver? Can you tell me what are the functional elements? Please write in the chat box. I just want this session to be a bit interactive, so that I can help you understanding the concepts well, so that this can help you in solving the assignments. And actually this is the first set of assignments will be objectives, but in future the nature of the assignments will be maybe subjectives also. So at the core you need to have a good knowledge of these concepts. Okay, so I just ask you the question like, what are the functional elements? Okay, so what Madhusudan, you tell me that make a close shape without hurting the skin. Okay, so basically what you define is more like what this particular form define. So what you try to answer is what this form or the concept, I'll say concept as a alias word, so that you understand these two terms together. So what you define is like, you say it like make a close safe. So, but what you define is basically what this particular form deliver. So that's the role of the form. Okay, so what you define is like make a close shave without hurting the skin. Okay, so that's a conceptual requirement. This is not a functional requirement, so I'll come to that. So what are the functional entities? My question was, what are the functional entities? So let me explain. So see, the functional elements here are, see, you have a rotary cutting blade. So this is a cutting mechanism. Sorry. Okay, so this is a cutting mechanism. Uh, Cutting mechanism. So overall, if you see here, there's a button. Okay, so this is to switch on or switch off. This is a button to switch on. Okay, so these are the button switches, and then we have this particular handle. Now this particular thing is defines the handle. Okay, so this is the handle. Okay, so basically the function defines how these elements, see this cutting mechanism, the the switch, the underlying the motor. You have a motor inside, you have electronics. So you have electronics, you have motor. So the form define how these elements of technology or engineering knowledge can be integrated to deliver the operational requirement. Okay, so that's what the form functional aspects. Now what the form define? The form actually define how structurally these elements are held together. So where the cutting mechanism should be. So it define the outer hull. Okay, the shape of it. So if you talk about the form aspect, so it define the where these buttons are positions. A lot of people are joining late, so I have little difficulty in writing here. So what form defines, like the structurally how these components actually serve the overall purpose. And what is the overall purpose? As I defined earlier, like someone like Madhusudan, he told that, he said like a make a closer safe without hurting the skin. So this is basically the requirements that actually the form try to solve by structurally holding these functional elements, and then trying to figure out the ergonomics, the ergonomic human factor of the device, the arrangement of the components, the positioning of elements, and the look, styling, everything. So all this comes under the form. So any doubt? uh, okay, so please feel free to ask if you have any query. Okay, because I just want this session to be interactive, so that you guys get clarified on the core concepts what have been provided to you in the NPTEL sessions. And since this is the third year of the NPTEL course, those are now you will be able to only get the pre-recorded sessions, so there will be no live session there. So that's why I'm taking this extra live session class. So this in this class I am covering the week 1 concepts, and if you have any queries, please feel free to ask. Okay, so I'll move to the next part. So tell me how this product evolved over time. What do you think about the previous generation of doing this particular purpose, or like what are the previous generation devices that serve this purpose? So my question is, what are previous generation solutions to serve these functionalities? Okay, Arusi, I'll just go to the previous slide. Okay, any doubt? Okay, you can ask via mic also, or you can write in the chat box. Do you have any doubt? Okay, so did you join late, Arusi?
No, sir.
Okay, okay. So how this product evolved over time? Have you attended the second class, a second lecture on birth of a product, birth and growth of a product? Okay, Madhusudan, single blade, razor, electric console. Okay, you're right. If you see uh, in early days we have, if you go to the barber shops, you have a wooden handle and there is a steel knife. Okay, this is like wooden handle, and then we have steel blade. I think only boys will know these things better. Even girls also will know this. Okay, so what are the solution before this? Can anyone tell? So this is the okay. Let's tell you that before this, people used to have use their knives, their household knife to save their beard. Okay, and then we have these particular tools which are used by barbers. So who are the user? Barber. So user here is the barber, and you will get these in saloons only most of the time. And then you have your the commercial razor, that you get. So you have a I think, okay, this is like the blade. You have the blade. So this is where a blade come into picture. So this is something where the cutting blade, which was earlier a big piece of steel blade, now comes to something like a form factor of a blade. And there actually you can use a case, okay, one on the top, one on the bottom, which you where you actually you sandwich the blade, and then you use this to shave. Okay, so who is the user here? Can you tell me? So who is the user here? Well, you know barbers still today use these kind of shaving blades, and mostly this product was introduced, this razor, oh sorry, spelling mistake, this razor was introduced to consumer, as a consumer product, to people. Okay, it's not for commercial use initially, and it was used for people, and it was sold as a consumer good. Okay, after that you have these versions, so where you have some like a trimmer, you have a trimmer, and then you have a shaver, and these are electronic. Okay, electronic or electric. Okay, and these are again for consumer. So these are consumer products, consumer grade products. Okay, tell me why this happened, why this particular product evolved to this, the current state of this product. Why we have a knife, then we have a wooden handle, and then we have a razor, and then now we have this state of art electric saver. So what is the requirement, and why there's a evolution? Okay, RUC says save time. Okay, so I'll just try to write your comments, okay, so that everyone can see. So these are the comments I'm getting. Someone like RUC says it is for saving time. Any more reply? Okay. So what are the limitations of effectiveness? Okay, now effectiveness is very like who Madhusudan. Okay, effectiveness. He said effectiveness. So these are now very vague terms. I mean, like you need to be a bit specific. Effectiveness in terms of functionality or in terms of usability, a lot of things are there. So effectiveness is very generic terms. Actually, most of the time we call effectiveness as from the perspective of engineering efficacy, you know, and that's where we define it's like engineering efficacy. Those like are the standards what we are used to as an engineer. However, when it comes to the field of design, okay, you will see effectiveness is also a measure of usability of a design. Okay, so there are a lot of different ways how effectiveness can be defined. So I'll just consider effectiveness. Okay, one of the thing, development of technology. Okay, Mahendran, he said development of technology. Okay, so let's see how. Okay, see what was the limitation of this particular blade. Although it still exists in the barber shop, why this cannot be used, and why you need to introduce something like a consumer product. Like you have a commercial product, and then there is a consumer product. Someone says save time, that's correct. Someone says it's development of science and technology. Let's figure that out. And the one is effectiveness. Okay, effectiveness can be usability also. Let's see. So what happens, like when you use a blade like system like this, there are a lot of chances that there are cuts and bruises. Those are some of the things that happens whenever, if you are not skilled, if you. Okay, see, the limitation with a blade and this little handle blade which is used in barber shops. Okay, a lot of people are joining late. Okay, is that there can be cuts and bruises because there is some sort of skill dependency. So you have a skill dependent. This is skill dependent. Okay, this one is skill dependent, so it can cause cuts and bruise because you need to cut it at some particular angle. So you have your face, so you need to cut it in particular angle. Otherwise, if it is more than that particular angle, it will cut and it will cause certain bruises. So the barber who is skilled in this particular art, he can only do it by himself. That's the reason why you have something like a razor, so which actually take care of that cutting angle by automatically pressing this particular blade against these two metal pieces. So when this is sandwiched, what happened, you have that blade at particular cutting angle. Okay, and there the chances of cuts and bruise are less. So you have a low chances of cuts and bruise. Okay, so that's a USP. And this is actually the problem. That's what this particular product solve over this. you know So I will call the transition from here to here. So the transition from the blade to this razor is need driven. Okay, because technologically, someone says that development of technology, because at this stage, you have all the same materials, like you have a steel blade here also, steel blade here also, you have a handle here also. There is not much that industrial engineering or industrial evolution brings here, between these two particular design. However, what changes happened here is that now this particular design solves certain limitations which was earlier occurred when you use a this kind of barber blade. Okay, got it? Any doubt here? Okay. However, if you see the next part, when you have now a blade, now you have this particular device. This is, again, it has certain user requirements. For example, since the issue with a razor. Okay, can you tell me the issues with a razor? Use the chat box. And how this electric saver will be a better solution? Yeah, it can cause some cuts, but compared to this, it is less. But yes, still there are chances of cuts and bruise. And the another factor is that uh, you know since this is it's a stiff structure, it is difficult to cut all the corners of your face. To access particular portion of your face, you need to actually tilt the orientation of the razor. And since this is like something like a rectangular structure, and the shape of the blade is also rectangular, now you always need to adjust your face accordingly. You always need to adjust your face accordingly. uh, oh, a lot of people are joining late. Okay. So there is a need for, because of stiff structure, you need to adjust. So you need to adjust what? Your head position. So if your face is like that, you need to move your face up sometimes, face up. Okay, sorry, difficult to represent here. But sometimes you need to face up, sometimes you need to face down, and you need to move your head and need to adjust accordingly, and then to use this particular razor to cut different sides. So you have those issues, and then also you have a something, because of the technological development, people have thought about, like, okay, we can use something like a something we can use electric or electronic, and then can you use some sort of electrical cutting mechanisms. Maybe it is a inspiration from some of those grass cutters, and then people have arrived at this. Okay, so the transition from a razor to a electric is not only need driven, but it is also is influenced by technology. Okay, So that's how a product evolve over time. Product evolve. So that means what I try to define here is two aspects. So let me ask this question to you. So what do you now understand? What drives the product evolution? So I explained this, and now you tell me what drives the product evolution. Yes, grip is also a good. Arusi told me that, okay, you can have, here there's not much grip, but here you have a more ergonomic and better grip. Okay, so that's also a valid requirement which is fulfilled by this electric razor or saver. Okay, so what drives the product evolution? Please try to answer this. You can use the chat bot, or sorry, not chat, that message box to write your answers. So what drives product evolution? Okay, so no answer. So basically, as I told, like product evolves because of two things. One, if there is a need, there is a need or a problem, okay, with the existing solution. Okay, and the particular point about need is that need is always evolving. A need always evolve, and that's the reason why product always evolve. And whenever a need saturated, the need gets saturated, you have a product saturation. Okay, for example, if you attended the class, the first week lecture, Professor Asokan has told you that why the design of a safety pin did not change over time, because the need reaches a saturation. So need reaches a satisfaction or saturation or a satisfaction. So that's the reason why you do not require any new design for a safety pin. So need is one of the driving factor which leads to product evolution. The other aspect is the technological evolution. The technological evolution. So what happens whenever new technology comes? The developers always think how these technologies can be implemented in new products. So this is not from this side, from the perspective of a user requirement, but how you have a like a technology, like nowadays you have speech user interface. We have like a earlier we used to have just a graphical user interface. So most of the early designs of smart the phones, the earlier tactile phones, if you see, those are like button based keyboard. Now we have a speech based interface, then you have a computational power, so high computational power. So all this adds to have a new phone which is a smartphone. So that's the reason why a product evolved from a from a normal tactile phone, like a button phone, to a smartphone. So the driving force here is the technological evolution. So these are the mainly two two drivers of product evolution. So any doubts here? Okay. Okay. So have you heard about these two particular terms, synthetic and analytical method of design? Can anyone define what is synthetic and what is analytical method of design?
Yeah.
Uh, let's try to define. You can use the chat box or chat box also. In the message box, you can write your answers. Okay. Okay. So Madhusudan said like analytical means to solve an existing problem, and he's right. So an analytical method of design comes when you are trying to solve a existing problem. Okay. So when you are trying to solve an existing problem and you want to make a present undesired scenario, we present, so this is like a current undesired scenario to a better scenario, so better desired scenario. So for example, the case where you have a, the barber blade, and then you have a transition to a razor blade, and this razor blade is a case which is called analytical design. This is based on the principle that, you identify a problem, then you try to solve that, and you come up with a solution which serve the purpose, and satisfy the customer requirement. So that is, it satisfy basically the customer requirement. Okay. So this is analytical. What is synthetic? Synthetic can be anything. So it's like anything, but not from the perspective of a need or a problem. Need or a problem. So for example, synthetic can be like a technology driven. Okay. A technology driven approach can be a synthetic approach. Another can be like a style driven. You like the look and feel of a new smartwatch, so that's why based on the styling you are changing the design. So this is not technology, but it's a style driven. Okay. So then there can be like, uh, there are different things, like, when there are other requirements, like other ancillary requirements, like availability of parts, then market demand, which is higher profitable. So based on those also, if you design, it is again a synthetic method of design. Okay. So now we have covered some of the basic concepts. So have you uh, remember this particular model? Can you tell me these missing uh, boxes, not boxes, this ellipse, like what this orange color ellipse suggests, like what should be there? Please try to answer these. Okay. So orange is basically knowledge.
First is related to engineering design, second is related to industrial design.
Okay. Function, yes, these are outcomes. And what about red? Need. Okay.
Engineering function.
Okay, and then need. And here evaluation. Evaluation. Okay. So Madhusudan, you are right. But you need to you don't club engineering design and then needs. Okay. And again here also, when you say function, don't define function and form here because these are outcome. Okay. So let me first tell you, first ask you. Okay. So what this particular model signify? So what do you mean by this particular model? Why we have this particular model?
To distinguish between engineering design and industrial design.
Okay, so that is one of the classification, that one of the thing that you can derive from this particular model. So basically, this is a theoretical model. Okay, what is this? This is a theoretical model, and what it represents? It represents the various factors that influence a product design scenario. So it what it defines is various factors that design, or sorry, that influence a product design and how. Okay. What are the key factors here? Are these three are the key factors? What it says, like when you want to design a product, you basically have one factor society, the other factor is technology, and the product itself, and they influence each other to to bring the requirement or the existing of a product, for the existing of a product. Okay, so these are the key factors. And how? So how is like, whenever you have a, so this particular society, you have a society, so there are certain contextual requirement. So what do you mean by contextual requirement? Is that we have a contextual contextual requirements, mean depending upon context, it can be a need. Okay, it can be a problem that you are trying to solve. Need can be just a like a desired situation. A need can be also to solve a problem. Okay. Okay, so basically, when a society have a problem, and you, the next thing you do is you identify the contextual requirements, the needs that is desired to be solved. Okay, and this particular need or context actually influence the design of a product. And as an outcome, so this is like an input, this is like an input from this particular phase, so input from society. Okay, and then as an output, you give a service to the society. This is the output as a service to the society. Okay, and what you actually give here is something what is called a concept. The other earliest term what you were taught is form. However, form actually does not define exactly a concept. From the engineering, creative engineering design perspective, a form is equivalent to a concept. However, if you talk from the perspective of design, a form is more like a convex hull, or sorry, a not convex, like the exterior structural hull, the shape, and the concept is everything. Like it basically it's the idea which actually you created to solve that particular problem. Okay, and form basically represent that particular concept. So a concept is represented by a form. So form is the ultimate, you can say ultimate output, the outcome. See, we have a concept. So a concept can be in the form of a flow chart also. You have certain idea like, okay, we'll do that one, then we'll do that, then we'll do that. So this is a concept. However, this kind of concept does not give the illustration like how this particular idea will do this particular service. So then you need to represent it in terms of a form, and this actually represent the concept, the same concepts. Okay, the other aspect is like whenever you have a concept ready, okay, you have a concept, now you have another set of needs. Now next thing you try to plan is like how to actually uh, make the concept into reality. Lot of people join late, and that is where you actually harness, you go to the science and technological field, you gather information there, and then as a output you come up with knowledge. Okay, and that knowledge you use for the design of your product. So this is where the product design happens. Okay, so do you know what this particular portion define, this particular portion? Yes, so this is basically engineering design. Okay, and this is what is represented here is your industrial design, and a product design is basically a combination of both. So that's where you cover both the form aspect as well as the functional aspect. So the outcome here in engineering design, when you actually, the requirements you establish here is more of a functional requirements, and then you follow the domain knowledge from the science and technology domain, and then you come up with certain knowledge to arrive at particular function. Okay, and that's where you contribute in the design of a product. Okay, so any doubt? Okay, okay, let's move to the next part. So okay, so can you trace the synthetic and analytical method of design in this diagram? Okay, let me define it. So basically, if you see here, a need arrives from the society, and this is where you have the industrial design, which is also known as conceptual design, and there actually you deal with product concepts and product form. And when you have this particular motivation of a need or a problem, we call it as a analytical method of design. So we can trace that analytical method of design follow this particular path. We move from left to sorry right to left, from right to left. Okay, this is also called where product sorry concept follow functions. Sorry, this is the opposite one. Uh, uh, okay, so this is also called that function follow form. Okay, because you come up with concept first and then you come up with the function, and then we sandwich together to do the product design. So this is function following the form. The other part is the synthetic part, where because there is a technological leap, you come up with the functional design first, product functional design or innovation happen first, and then you try to come up with the form or the concept. This is what also called as form follows function. Am I clear? So tell me one thing, like you have a aircraft, okay, like a super fast, like a Rafale. What do you think the the design of this particular nose, is it a synthetic design or a analytical design? So we have a nose of a aircraft, right? Or again we have these the wings, so they also come with certain profiles. So what do you think, is it a concept driven product, or is it a need driven product, a concept driven product, or a technology driven product?
Technology.
See, in most of the cases it happens from both the sides. Okay, we cannot say it like whenever there are very few examples where you can say, like in the case of smartphones, when there's a technology, and then we, because of the technology, we actually come up with a new product. But in case of this kind of product, you have some sort of requirements, and in most of the cases, at a high level, very high level, these are societal requirements. For example, if you talk about defense, countries defense, the high level, these are societal requirement. However, when you come down in the hierarchy, you will require the technological requirement, like for example the aerodynamics. You want a fighter, but you need to know the aerodynamics of it. So basically what I am trying to say here is that the particular form that actually people come up for a aircraft is something what is called as form following the function, because these forms are highly influenced by what the role of aerodynamics. because we can have, if it is purely driven by concepts, then in the past we have different kind of concepts, like alien ships kind of concepts in designing in aircraft. We can have something like a, there's a different design for a ballistic missile for the tip, and there's a different design for the tip of a aircraft, because you also need the requirement for having a visibility. Okay, it is not like a missile which is like a, which can be just like a round or like a dome kind of structure. Okay, so these are highly influenced by what technology is defined, what is the requirement of aerodynamics. Okay, so this is how you try to distinguish what drives this particular design. Okay, even the wings of the aircraft is also designed in such a way that you have, you know low drag, and you can get lift when you move forward. Okay, so there's a science behind, like whenever air flows, this air reaches there faster, this air reaches slower, so there is a vacuum created, then there's a lift. So these are all driven by, the technology, the functionalities. Okay. Okay, so we already defined like what is engineering design and what is industrial design by, writing, like marking these particular two areas. I'm saying that this is engineering design and this is your industrial design, or also called conceptual design, represented as form. This is also functional design, represented as a engineering design or product function. Okay, and can you tell me what is the difference between these particular need areas? So we have both industrial design side have a need, and also we have a need from the engineering design side. What is the difference between these two particular needs?
The left side is essential, right side is optional.
Left side is, I mean, left side means this is
Yes,
essential,
essential.
and this is, you are saying, optional.
Optional.
Okay, okay, I think that is not correct. Okay, both are essential, both are essential, but the nature of these particular needs are different. you know I mean, it is always true that, see, if I talk to a person who is an engineer, he will think like the engineering portion is driving mainly the conceptual part. So that means the person is thinking from the perspective of a synthetic method of design, and there is nothing wrong in it. Similarly, if you go to someone who is working in the industry as an industrial designer, if you ask their perspective, they will think like it's their design which is driving the functionality of a product. So, but then we call their method of design is more like an analytical method of design, and there is nothing wrong in it. Okay. However, in reality, both are essential. The difference is that here in industrial design, we do a set of activities. So what are the set of activities? We do various activities, like, you do primary study, secondary study, then that can be a contextual clinical immersion can be a field study, depending upon your domain. That can be, then you gather information on user requirements, you try to identify a problem. Okay, and then you come up with some sort of needs, and then you evaluate those needs, you know and then you select a set of needs to be solved. The nature of this work is qualitative in nature, also can be quantitative, but this is something where we are trying to identify the needs or the requirements from the society and try to evaluate. So we are evaluating against a matrix where we are considering the societal requirements. Okay, so we are considering societal requirements to evaluate those particular needs. However, in engineering design, when we come to this particular section, we already have a concept, and now we are trying to understand like how we can bring a product into reality. So the goal is to bring, so goal is to bring a,
Sorry, sir. Actually, it is not optional. Additional, you can say. Can you say the second one?
oh,
Right
I
side
just
one.
maybe I heard wrong. Okay, okay. So to bring a product into reality. Okay, so when you try to bring a product into reality, you have a concepts. For example, the example of a saving thing, right? I'll give the same example. So you have a that previous, the previous barber blade. Okay, then we come up with those such set of requirements, and the nature of these requirements are qualitative. If you see, these are qualitative. So you have the qualitative requirements more like should not cut, easy to handle. So nature of these requirements are qualitative in nature. However, you again derive quantitative measures to actually come up with certain concepts. However, concepts are intangible, like it's not actually solving the purpose. What at the end you need to deliver the particular product in reality. So they are actually based on the concepts you come up with what are the engineering requirements. So this is where you try to figure out the engineering requirements to to fulfill this particular concept. What sort of engineering modalities, science and technology, or the knowledge domain expertise I will be requiring, those will be the needs of this particular area. And that's we search in the space of science and technology, and we come up with knowledge or functions, and then we use them to come up with a product design. Okay, now this example I have given as an analytical method of design. I come up with the problem from this side. Okay, but the example can be also from the other side. We have something like a AI. Okay, for example, we have to nowadays conversational AI. Conversational AI means those chatbots. Okay, like chatbots you used in the websites. So now we have a technology, so there is no requirement. However, it is again a need derive, which is synthetic in nature. So based on that need, now you flow in the reverse direction. Okay, you take that knowledge. Okay, and in the space of science and technology, you come up with that particular requirement, which is artificial. So that requirement, for example, to add this particular modality, conversational AI modality into a smartphone. So that's where you have a product like Google Voice Assistants. Okay, so that's, I gave an example. It may not be a perfect example, but this is again the same thing. I'm just trying to here clarify the nature of these two particular need. Okay, however, both are essential, both are important. You can tell these are like soft design soft design requirements, and these are hard design requirements. And that does not mean that this is because this is very hard to do, that's why it's hard, and this is very easy, that does not mean. These are like terminologies, because this is a bit more superficial, this is more a bit grounded. to science and technology. Okay, am I clear? Okay, so let's give an example. So this is one of my work in the industry. So I was in the industry for around 10 years. So I was a lead designer in Tata Elxsi, and also I had two startups in the space of medical design. So this example is I'm trying to give from the perspective of an analytical approach to design. So the situation is that, so I'm trying to give you an example, the nature of a societal need. So the problem is that you might have seen the shampoo sachets, okay, like the sachets which are available in the form of strips, okay, like Dove, Sunsilk, all those are available in silk. However, those are available only in small, grocery shops or kirana shops. Okay, so these are available in small shops. So these are available only in small shops. And if you go to a mall scenario, you will find most of the time these shampoo bottles, which are expensive. If you compare the quantity of shampoo you get inside these bottles, however, you do not have the option to get these here. Okay, so no sachet strips. Okay, so we did a field study, back in 2013, and then we come to know about this scenario, and we are given the problem as that it is hard to manage these kind of sachets because there are 100, for example, there are 40 companies and they have different sachets, and then managing them in a mall is really cumbersome. It's not easy. Like you need to have particular self, and also billing those. Billing is also a problem. So billing sachets here is a problem. So you have issues like billing. So I will just try to write down the issues. Like you have billing issue because first people can take X amount of sachets. So you have to count individually, and then these things. And there are chances of tear, and like shampoos can come out. Shampoos can come out of sachet. So it's not a very hygienic business to be adopted in a mall scenario. So that was the requirement, and that was the problem. And the requirement that was identified was that why we can't have something like a dispenser, automatic dispenser, and that actually that will store sachets, and that also can be dispense sachet as per user requirement. Okay, so this is the requirement. So nature of a societal need is more qualitative in nature. Okay, so this particular solution later can be used in both the scenarios. So that was the agenda. Now let me give you an example of the industrial design outcome. The nature of an industrial design is, again, as I told you before, are concepts. The concepts means ideas. So generally in the industrial design phase, we created lot of concepts. Concepts. And out of those, we select particular concepts which fulfill and satisfy all those societal requirements. So you satisfy all the societal requirements. So in this particular project also, we have come up with lot of concepts, and this is one of those final selected concepts. Okay, now if you see here what actually the industrial designers do in this particular phase, the industrial designer plan about how this particular product will be positioned in a mall scenario. So stacking or positioning in a mall or retail outlet. It's try to define this particular shape, because from the human factor ergonomics point of view, for easy visibility, if it's your eye, this particular angle of 60° is something suited in most scenarios. Okay, so this particular form or the shape has been taken care. Similarly, where, so what sort of features it should have. Okay, now this is not engineering design, but a designer, the industrial designer, can actually ideate, because the other concepts which he may come up with may not have a LCD display. Okay, but this was selected, that's why I'm explaining here that the industrial design outcome also come up with something like ideate. So the person ideate that this is a LCD, and from the bottom, there should be a sleeve from where the shampoos will come out. The other requirements which the industrial design person try to ideate is uh, the machine should be able to dispense sachets of any number, of any number. So these are like desires. That means the designer does not have a real solution for all this. He do not know how to achieve this, but he desire, as an industrial designer, that this essay should come as a user defined a number here. If a person say 3 essay and he press OK, then 3 essays should come, something like that. So this is some kind of concepts, and that person tries to define this in this particular form factor. Now there are style elements, styling, which are also outcome of a industrial design, because styling matters, because you want to make this particular competitive against other products. Tomorrow if different products comes, your product should be staying competitive. So these kind of decisions can be taken care by industrial design, by working on the aesthetics. So aesthetic is one of the thing that they take care. And apart from that, they also can think about simple ideas of how this can be implemented. And this is not something very complicated. This is what a designer, a industrial designer, can actually think about. So now you may argue like this is something like an engineering design. Of course this is part of engineering design, and in most cases whenever industrial designer actually come up with concepts, sometimes he also come up with some of the solutions which are influenced from his knowledge of technology and science. Okay, so it's good that a person who is a industrial designer, he has some sort of scientific knowledge also, so he also can have science and technology. So basically in science and technology we can have three type of knowledge. Like we have something like past technology, or science knowledge that you come across in your school books. Okay, so any designer who have finished their bachelor's or graduation, or the initial even class 11 12, they know basics of physics chemistry, so that serves the purpose. So that will help them increase, help them as their domain knowledge in ideating is simple solutions. The second set of knowledge can be like what is currently happening, you know, currently happening from uh, from the existing products or the exposure. exposure to other products. So this is also something from where a industrial designer can have some sort of exposure, domain exposure. And other thing which is like future technologies, which rarely industrial designer have access to. So most of the time whenever an industrial designer design, their concepts come up with these sort of outcomes. They work on ergonomics, they work on form, they work on the styling, they work on the positioning of the elements, positioning of various elements. And if they have some sort of exposure, they also try to define those, like a rough idea. However, the intricacy and the detailing, like the exact requirements to bring this particular concepts into reality, happens in the industrial design phase. And this is a nature of a engineering requirement. Okay, so if you see what are the engineering design requirements, so based on the concepts the person come up with the solution. Actually this is my work only. So basically design needs a sachet holding unit. Okay, the requirement is that this particular chamber needs to hold sachets in particular format. So how to store is a question. Okay, so how is a question. And how to feed to some sort of dispensing mechanism. Okay, so as an engineering design requirement, a designer or engineering designer, he come up with these particular requirements. As per his requirements, he thinks like to solve these particular concepts, he need to come up with a sachet holding unit, he need to come up with a dispensing unit, he need to come up with a some sort of detecting mechanism. This is like detection mechanism. And then he should have something for cutting the sachets. Okay, so these are the requirements. And what are the reasons and how he come up with these particular records? It is all based on his knowledge on science and technology and his domain knowledge. So that's why engineering design needs engineering knowledge, scientific knowledge to come up with these sort of requirements and solutions. Okay, for example, a dispensing mechanism, the person should have the knowledge about gears, levers. He need to have the knowledge how much torque is required to push that particular sachet. For the sachet holding unit, the person needs to have the knowledge of the dimensions of the sachet. So he need to consider the dimension. Consider the dimension and how to feed this. And if this is a particular sachet chamber, you should be also able to bring this out of this particular unit, so that whenever the sachet goes empty, you should be again able to fill this. It's like how in a ATM machine, a person access the ATM machine and fill the new currencies or not the notes. Okay, so a person needs to think about how to bring this particular chamber out of this particular unit. So that means he need to think this particular thing as a modular unit. All these decisions are taken care at this phase, engineering design phase. So again, in dispensing mechanism, how much torque is required, how to drive, you know how much what should be the uh, the specification of the motor, all those things. So these are mechanical design requirement. So mechanical mech engineering design. Again, you have electronic engineering requirements where you need to detect particular sachet. Like how we detected was that, like whenever there's a sachet, there is some sort of sleeves, right? So each sachets are separated by some perforated borders, and we try to detect the light, you know, across these particular holes. And for that, a engineer can thought about IR, LED, photodiode as a sensor. So then these are sensor requirements. Now again, the person has to have the knowledge of a, something like a microcontroller unit. So he need to have the embedded design, so embedded design understanding, software and hardware both, so that he can implement these particular concepts, the detection system. Similarly, in the cutting mechanism, like the engineering design involve, uh, like how, rotational motion can be converted into a linear cutting mechanism, how rotation converted. Okay, so those decisions, like, and how to drive this particular motor. Is it a stepper motor or a DC motor? All those decisions are taken, based on this particular design requirement. And above all, you also need a power circuitry to actually control. So all these requirements come from engineering design requirements. So in nature of engineering requirements are like this, and these are the nature of engineering outcome. Okay, so what we have are prototypes, okay, that actually represents the concepts, and we have hand skills involved. So material handling capability, it depends upon what kind of material we are using. This is like a prototype, but in commercial, if it is injection molding, or if it is a, die, or something like a vacuum forming. So all those decisions are taken at this engineering design phase, and as an outcome we can have, these are low fidelity prototypes, these are low fidelity prototypes, and these are high fidelity prototypes, and these again needs the knowledge of, CAD CAM to arrive at final product. So this is the final product. So what I'm trying to make you understand here is the nature of a need, societal need, the nature of an industrial design outcome, the nature of an engineering need, and the nature of an engineering design outcome. Okay, so let's see the product here. This was the Mark 1 version. This was a low fidelity prototype, and I did the engineering mechanism, the overall, both the industrial design part, okay, as well as the engineering design part. So the initial prototype can cut one sachet at a time. So later I did some sort of software upgrade and changed the dispensing mechanism also, and then the system was able to, cut multiple sachets at one go. So if I say 2 sachets or 3 sachets, it should be able to cut multiple sachets one go. So this involves both. No, this is again a outcome of an engineering design process. This is the final prototype, and this also involve CAD CAM, then injection molding, CNC machining, So this is the final. Okay, this is a high fidelity one. Okay. Okay, so that's the end of today's presentation. And just at the end, I want you guys to understand like how to map these particular design project, okay, into the model we learned in the week one of this lecture. So what we see here is the societal problem, okay, and then we have these requirements, and as an outcome the nature is a concept. Okay, there can be concepts also, and these are like this. That's what we understood. And there are then we have here the conceptual requirement. The next thing what we require is an engineering set of requirements. So for engineering set of requirements, we go to science and technology, and the engineering requirements we ideate first. Let me erase this. Okay, we come up with these sort of functional requirements. So these are functional requirements, and then we search them in the space of science and technology, and as an outcome we come up with functional modules or knowledge. Okay, you use that, the conceptual design as well as this functional design, and together we have the product design, and that's your final product. I hope I was able to give you the some of the key concepts from week one of this particular syllabus. And if you have any doubt, please feel free to ask.
Sir, I have one doubt.
Yes, please.
Here, industrial design means is it 100% conceptual design?
So that's what I just try to define in the industrial design phase here. So ideally the nature of a industrial design outcome should be this, like a person try to come up with a concept means ideas. Okay, so ideas, as I told you before, ideas can be in the
Concept is required. Industrial
industrial design.
design
Sorry, can you type?
is
Your voice
the
was
ergonomics industrial design.
actually not audible. Can you just write it down?
Yeah, the ergonomics and aesthetic appearance are also part of industrial design.
Yes, yes. So
If there are no aesthetic appearance, even the part can function.
yes,
It can
yes.
execute its function.
So these are not must have. These are
Mm.
like a product can have all of these. So you can have ergonomics, form, a styling, or any other things, okay, and ancillary. And then you go to your functional. I did not tell you that you should have all of these. There can be product which only needs to work on the form. That's it. You do not take care of ergonomics. For example, imagine the safety pin.
Yes.
Okay, so probably you just think about how to fold it in this particular form. So you come up with this particular form as a concept. In terms of engineering design, there is not much. Okay, so I'll give here one example. Like for example, you come up with the concept that this is a concept of a safety pin. There can be other concepts also. For example, you can think about something like a plastic safety pin, okay, with a cantilevered portion. Okay, those can be also concepts, but finally out of many concepts you selected these particular concepts. So you see, you just have played with the form. Now you are not playing with the styling, you are not playing with the ergonomics, all these things. Okay, and in terms of engineering,
Yeah,
usually
yes, sir. Concept should be there. Conceptual should be there, but it is not 100% industrial design.
I did not get it. So
Yeah, without concept, we cannot go for a product to get the form. Sorry, the function.
no, you
Uh,
can. So for example, I just told you, right, there are analytical method and there is a synthetic method. When you talk about the analytical approach, okay, we go from the problem, the need, and then come up with concepts and then move towards the functionalities. But the other way around, as I explained before, that actually there can be some kind of technological leap and then you try to use that technology to come up with the concepts. So I explained that in the previous slide.
yeah, yes. I'm able to recall that, sir. Yes.
Yes, so here I just tried to give you the example where form follows a function. You define a function and then based on the functionalities you define the form. Like a aircraft knows the wings of a aircraft. There are aerodynamics as well as the other factors. It is not purely styling or not ergonomics. Okay, this is something which is derived from the engineering requirements, the functional requirements. Okay, but there can be also the analytical approach where things can be from the perspective of a societal need. Okay, both the approaches are correct. We have in the industry both engineering designers and industrial designers, and I was lucky to be part of Tata Elxsi in as a lead designer. So there actually we had a big office. It's like an open area, and we had both the team of engineering design and industrial design working together. So when I tell you these, like, that means you actually have seen how the information flow passes from one side of design to the other. Okay, so in the
So
industrial design team, actually we have
tools like PLM software will enable this parallel path.
okay, okay, so that's again engineering design part. So you are saying what product lifecycle management.
Yes.
Okay,
Yeah,
so
both the designs will be happening in parallel,
mhm.
or
It
one
can
will be
happen.
executed after
It,
the other one based on the nature of the product.
Yes, 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 absolutely. Based on the nature of the product, it can happen from any side.
Yes,
Imagine
yes,
like you are making a vase for a flower vase. If you are making a flower vase, the things will come probably from the aesthetic side.
aesthetics. Right.
Okay, and imagine you are making something like a revolver. It will not be aesthetic product. It will be come from a functional perspective. Okay, so
Function.
depending upon your product, either it will be synthetic design or analytical method of design.
Um,
Okay, and it's not like this is superior, that is inferior. Okay, both side things can happen. Okay,
yes.
and nothing is like, as you told before, like optional, or both are important. And there are products which require the one side more better, and there are products which require the other side better.
Other
Okay.
side. So what is the textbook you are recommending, sir, for this?
Actually in the syllabus, like I just forget the name.
Auto is mentioned
Okay, so
product
yeah,
design.
just follow that. That is very important. And also you can actually refer course material from Professor Amrit Chakraborty from IIC Bangalore.
IIC Bangalore.
Yes, so he was my teacher when I did my masters in design. So his content is on creative engineering design, and also you can refer that apart from this particular course also. Okay,
So, what is the title, sir? Creative engineering design.
creative engineering design by Amrit Chakraborty. You can
Okay, sir.
go for search for that. Okay.
Thank you, sir.
Okay. So thank you everyone. If you
Thank you.
have any doubts, so I have my WhatsApp number. I will share my WhatsApp number as well as my I'll just write it here. It is okay. My WhatsApp number is. If you have any doubts, please feel free to ask. Okay, and the next class will be next Tuesday, same time, and please go through the week 2. Okay, week 2 lectures, and I will be taking live classes to clarify your doubts so that you will be able to answer the assignments correctly. Okay, and don't forget the deadline for the assignment. It is 10th of August. Okay. Okay, thank you everyone. Bye.
Sure, sir.
Yeah, please.
The assignment will have objective questions or subjective questions.
Actually week 1 is objective, and actually last year's, like most of the assignments were objectives, and I have requested this year to the faculty as well as the other TAs from IIT Madras to give you few subjective questions also. Week 1 is objective, then probably from week 3rd or 4th you may get few or 1 or 2 subjective questions. That will give you a hands-on experience probably, and I can better explain those things in a live session. Because today's session, if I try to answer the objective questions, no, it would not be interesting session, and also it would not be easy to conduct such a objective answering session. Okay. Any question?
Okay, sir.
Sir,
Okay.
can you please type the book name that you
uh,
just referred now?
let me check because currently I do not have. Okay, should I message you? Like, please do one thing.
Oh, you can. Yes, sir.
Refer the videos there. Okay, I will write here one of the course like creative engineering design by Amaresh Chakrabarti from IIC Bangalore. Okay, as additional content. Okay, so apart from these course material, you can also refer his lectures. You will have you'll also have a equal understanding of various topics. Okay, so his name is Amaret Chakrabarti from IIC Bangalore. Okay. Okay,
Yeah,
thank
thank you,
you.
sir.
Yeah, thank you. I'll leave now. Okay, thank you for joining, and the next class will be next Tuesday. And please go through week 2 lectures of conceptual and functional design. Okay, thank you.
Thank you, sir.
Thank you.